Namaste, my dear students, and a very warm welcome back. It's your favorite tutor, and I'm here with another super simple explainer to get you all exam ready. Today, we are going to absolutely master Chapter 7, all about matter. Ready to score full marks? Let's go.
Okay, so let's kick things off with a little puzzle. Have you ever been to the beach and wondered this? You can build these huge, amazing sandcastles, but you can't build a water castle, can you? The water just flows away. Well, this really simple question actually holds the secret to understanding this whole chapter. So let's find out why. So to solve our sandcastle mystery, we first need to find matter's secret ingredient. I mean, what are all the things around us made of? Your textbook, the water in your bottle, even the air you're breathing. What are they really made of at the tiniest level? Let's investigate. For our investigation, let's grab something you see in your classroom every single day. A simple piece of chalk. It looks pretty solid, right? Like it's just one continuous thing. But let's see what happens when we take a closer look. Now, what if we just snap it in half? We just get two smaller pieces of chalk. Easy enough, right? But what if we keep on going? And if we keep grinding it down, we get this fine powder. Now, here's the amazing part. If you could take the absolute tiniest speck of this powder and look at it under a super powerful microscope, you know what you'd find? It would still be chalk. This proves that chalk isn't one solid piece. It's made up of millions and millions of tiny identical units.
And these tiny building blocks, they have a special name. We call them constituent particles. This, my dear students, is the secret ingredient. Everything, and I mean everything, around us is made of these tiny particles. So, for your exam, remember this key point. Matter is not one smooth thing. It's made of tiny parts, just like a big building is made of many small bricks. Okay, time for another puzzle. When you stir some sugar into water to make a nice glass of nimbu pani, where does the sugar go? It looks like it just vanishes. Poof! But does it really disappear? Let's find out. Not at all. It doesn't disappear. Look closely at this drawing. The teeny tiny sugar particles, they simply break apart and then they fit into the empty spaces between the water particles. It's kind of like finding the perfect parking spot. So this simple experiment proves two very important things. One, that matter is made of particles, and two, that there are tiny gaps or spaces between those particles. Okay, so we know everything is made of particles, and they have spaces between them. But if that's true, why is a stone so hard, water so, well, flowy, and air totally invisible? The answer is all about how these particles behave. Let's find out in the particle dance, solids, liquids, and gases. Now, to make this super easy to remember, I want you to just imagine that these particles are students, just like you, in different situations at school. Trust me, this little story will make everything crystal clear. First up, solids. So imagine the particles in a solid are like you students sitting quietly during a very serious lecture. You are all packed tightly together in your neat rows. You can't just get up and run around, can you? No. You can only maybe fidget or vibrate a little bit in your spot. The force of attraction holding you all together is super strong, just like the teacher's discipline. Next up, liquids. Now, let's imagine it's the short break between classes. You are all still inside the classroom, but you're free to move around a bit, slide past your friends, and change places, right? That's exactly how particles in a liquid behave. They can move and flow, but they stay within the boundaries of their container, which is our classroom. And finally, gases. Okay, think of this as recess time. The bell rings, and what happens? You all run out into the big playground. You are completely free. You can run in every single direction, filling up the entire space. This is exactly what gas particles do. The attraction between them is almost zero, and they have tons of energy, so they just zoom around and fill up any container they're in. So, now that we have our fun school story, we can understand the scientific picture that you see in your textbook. See how the particles are tightly packed in the solid? And a little looser in the liquid, and then super far apart and randomly moving in the gas? See? That school analogy makes it so simple to understand. But hold on, there's one more secret of these particles. They're always moving. They literally cannot sit still, ever. So let's explore this constant motion. Just watch this simple experiment. A tiny crystal of potassium permanganate is dropped into a glass of still water. Now notice, we are not stirring it at all. But slowly, the colors starts to spread until the whole glass turns pink. Why does this happen?
It's because the invisible water particles are constantly moving, bumping into the permanganate particles and pushing them all around the glass. So, the main thing to remember is this. Particles of matter are in continuous, random motion. They're always jiggling and bumping, and this causes them to spread out and mix with each other, all on their own. This spontaneous mixing process has a scientific name you should know. It's called diffusion. And you know what? This happens even faster in gases. Think about it. When your mother lights an agarbatti in the puja room, that beautiful fragrance, it doesn't just stay there, right? No, it quickly spreads through the whole house. The fragrance particles are mixing with the air particles and traveling everywhere. You've probably seen those funny Instagram reels, no? Where someone sprays way too much deodorant and everyone around them starts coughing? That's diffusion in action. All right, my champions, with exams just around the corner, let's do a super quick revision of all the key points we've learned. Pay close attention now, this is very important for your marks. Okay, let's do a lightning-fast recap with this table. For solids, remember the classroom lecture? The spacing is minimum, packing is very close, and attraction is maximum. They can only vibrate. For liquids, that's the class break, right? Spacing is more, packing is looser, attraction is weaker, and that allows for limited movement. And for gases, recess time. Spacing is maximum, they are packed freely, attraction is almost negligible, and they can move all over the space. Take a screenshot of this if you need to. Got it? Perfect. Now, here's a classic exam question you might get. Why do two gases, like air and perfume, mix so easily, but you can't just push two wooden blocks together and make them mix? Think back to our student story. It's recess time versus lecture time. And here is the perfect answer for your exam. In gases, the particles are really far apart, with very weak attraction, so they are totally free to move and mix easily. But in solids, like our wooden blocks or the grains of sand in our sandcastle, the particles are packed tightly with super strong forces holding them in a fixed position. They just can't move around to mix with other solids. Simple as that. And finally, let's circle back to our very first question. Why can we build a sandcastle but not a water castle? Well, it's because sand particles are solids. They have strong attraction and they hold their shape. Water particles are liquids. They're loosely packed and just flow past each other. So here is one final puzzle for you clever detectives. We now know all particles are vibrating, so why doesn't your solid study table just wiggle away? The answer lies in the strength of that particle dance. Think about it. Keep that curiosity alive, and I will see you in the next explainer. All the very best for your exams.